Welcome to the course of differential equation. In this session, we will discuss about the second order homogeneous linear differential equation with the constant coefficients, which part 3 we will discuss here. We already discussed about the general form of second order linear homogeneous differential equation as y double dash ay double dash plus by dash plus cy equal to 0. This is our differential equation. Here a, b, c are constants, are the constant values. Okay. So, here we discuss it is that maybe e raised to mx is a y is equal to e raised to mx is a solution of this differential equation, and we found the y dash and y double dash, and then we found that there is an auxiliary equation for this differential equation, that is the auxiliary equation for this differential equation. One is, or sometimes it is called, instead of auxiliary equation we may call it as characteristic equation maybe. Okay. So, the auxiliary equation is am square plus bm plus c equal to 0. So, this is a the auxiliary equation is a quadratic equation in m. So, that is why we can find the value of m, that is equal to m is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay. Here we discussed the two cases in the previous sessions, that is whenever b square minus 4ac, we discussed case 1 as b square minus 4ac is greater than 0, then the roots m1 m2 will exist, are real and distinct. The roots are real and distinct. Okay, the roots are real and distinct, and we already discussed the general solution of the differential equation is general solution of differential equation. General solution of the differential equation is y is equal to c1 e raised to m1x plus c2 e raised to m2 of x. So, that is the general solution of in the case b square minus 4ac is greater than 0 in this formula. Okay, if b square minus 4ac equal to 0, that we discussed it is here m1 m2 are equal, and we already discussed the case 2. We discussed the case 2 as if m1 and m2 are equal, if b square minus 4ac, if b square minus 4ac equal to 0, if it is equal to 0, then we say that this one m1 is equal to m2 is equal to a single value, that is the double root, the case of a double root. That is a case of a double root, and that is a case of a double root. Therefore, the general solution will be solution is y is equal to c1 plus c2 x e raised to mx is there. This is the general solution in this case. See, so these two cases we already discussed. Now we just move to the case 3. In case 3, if the discriminant b square minus 4ac, if the discriminant b square minus 4ac is less than 0. So, b square minus 4ac is less than 0 means that is the minus b plus or minus b square minus 4ac is there. So, we can say that this is equal to m1 is equal to minus b plus root of b square minus 4ac divided by 2a, and m2 is equal to minus b minus root of b square minus 4ac divided by 2a. Okay, so definitely we can say that since b square minus 4ac is less than 0, there will be a negative value inside the root, the negative real value inside the root. Therefore, this will be the complex numbers, and this is minus b plus I into some a complex number divided by 2a. This is minus b minus the same complex value divided by same imaginary value divided by 2a is there. So, simply we can say that that may be, suppose this is, if this is p plus iq, for p and q are the real numbers, then definitely the m2 will be the p minus iq. Okay. So, in this case, if b square minus 4ac is less than 0, then the roots of, that is roots of auxiliary equation is complex conjugate or complex conjugates. The roots of auxiliary equation are complex conjugate. The roots of auxiliary equations are complex conjugate, that is p plus iq and p minus iq. Our thought is that how can we represent the general solution? Therefore, the general solution we use to write, therefore, the general solution will be, the general solution can find by using the formula, general solution can be found by using the formula y is equal to, that is e raised to px, y is equal to e raised to px, and a cos, an arbitrary constant a is the a cos beta x plus b sin a cos beta x b sin beta x, a cos beta x plus b sin beta x is there. So, find a cos beta x plus b sin beta x is there. Find, sorry, a cos, sorry, there is a mistake that I had done here. It is instead of beta we use qx. We already used here. This is p plus iq, because p plus iq e raised to px into a cos qx plus b sin qx is there. Okay, fine. Now, this is the general solution for the differential equation, linear differential equation with the constant coefficients in its auxiliary equation if the b square minus 4ac is less than 0. See, my dear students, so we discussed here three types of are already discussed here. See, in this all discussion we discussed here that already we discussed here. It is the this is our auxiliary equation. Okay, or sorry, we already discussed about our auxiliary equation and the basis of the differential equation. That is the differential equation is ay double dash plus by dash plus cy equal to 0, basis of the differential equation. Then we already discussed is the general solution. We discussed the general solution. So, my students, the auxiliary equation is we can find, and the roots of auxiliary equation is a lambda square plus b lambda, a lambda square sorry, we used here it is m, therefore we use like that, am square plus bm plus c equal to 0. So, their roots are, first one is m1 and m2 are real and distinct. So, in this case we discussed it is the basis of the differential equation is e raised to m1x and e raised to m2f x are the basis. Okay, fine. Therefore, the general solution is y is equal to c1 e raised to m1 x plus c2 e raised to m2 of x. Okay, by fundamental theorem we can say write like that. Okay, fine. Now, if in the case if m1 and m2 are equal, m is equal to m1 equal to m2. They are real and equal, m1 equal to m2. So, in this case we can say that the first one is in the basis by fundamental system e raised to mx, and the second element in the basis x e raised to mx is there. Okay, fine. Therefore, general solution is y is equal to c1 plus c2 x e raised to mx is the general solution. Okay. Now, finally, we just discussed the third part. The third part is the this one, if the roots of auxiliary equation is p plus iq or p minus iq. That means the root may occur in as complex conjugates. So, in this case we will we can say that if m is equal to m1 is equal to, that is the complex conjugate value p plus iq, and the m2 is equal to the roots of the auxiliary equation is the second root is p minus iq. Okay, p plus iq and p minus iq. Then definitely this one, the auxiliary equation is p minus basis of the differential equation is e raised to px into cos qx, and similarly the second element in the basis is e raised to px into sin qx. Fine, sin qx. So, the basis elements are e raised to px into cos qx and e raised to px in sin qx. So, their linear combination will be the general solution by the fundamental theorem. So, we can write this is equal to, general solution is equal to e raised to px into a cos qx plus b sin qx. Okay, fine. So, these are the three forms that we already discussed. In the case of general solution, if the roots are real and distinct, then yes, y is equal to c1 e raised to m1 x plus c2 e raised to m2 x is the general solution. If roots are real and equal, y is equal to c1 plus c2 x e raised to mx is the general solution. If roots are complex conjugate as p plus iq and p minus iq, then definitely the general solution is e raised to px into a cos qx plus b sin qx. Here a and b are the arbitrary constants. So, my dear students, so we can move to questions. In example 1 we will discuss. In example 1, solve, we just write solve y double dash plus 10 y dash, solve y double dash plus 10 y dash, y double dash plus 10 y dash plus 29 y is equal to 0. 29 y is equal to 0. Y double dash plus 10 y dash plus 29 y is equal to 0. Okay, fine. See here we can write the auxiliary equation. Before solving this equation, to solve this equation, we write the auxiliary equation as, or the characteristic equation as, auxiliary equation is, what about the auxiliary equation? The auxiliary equation is actually lambda m square plus 10m plus 29 is equal to 0. Find m square plus 10m plus 29 is equal to 0. See, dear students, we can have the formula m is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Definitely we have the values of a, b, c can find from here. We have the values of A is the coefficient of m, that is equal to 1, B is the coefficient of, A is the coefficient of m square, that is equal to 1, B is the coefficient of m, that is equal to 10, and finally we have the coefficient of C, the constant term, that is equal to 29. So that we can replace here the value of m can find by using the formula minus b plus or minus root of b square, that is minus 10 plus or minus root of b square plus or minus minus 10 plus or minus square root of, that is b square is the 10 square, that is 100 minus 4 into a is 1 into 29 divided by 2a, 2 times of a, that is equal to a is equal to 1. Okay. So, minus 10 plus or minus is equal to, that is m is equal to minus 10 plus or minus square root of divided by 2, the square root of that is 100 minus 4 into 29, that is 4 into 29 is equal to 100 minus 4 into 29 is actually 116. Okay, 116. Fine. Therefore, this is equal to minus 10 plus or minus 100 minus 116 minus 16 divided by 2. So, okay. So, we can say this is equal to minus 10 plus or minus root of minus 16, that is equal to I root 16 divided by 2. Okay. Is equal to minus 10 plus or minus I root 16, that is equal to minus 10 plus or minus I into root 16 is 4 divided by 2. Fine. So, we can take 2 is out and then cancel this one. This is equal to 2 into minus 5 plus or minus I root 4, instead of 4 we just take 2 is outside, therefore 2I divided by, minus 10 from, we can take 2 from here, we can take 2 from here. So, 2 into minus 5 plus or minus 2I divided by 2, 2I divided by 2. Okay, fine. Therefore, we can cancel this 2 and 2 we can cancel, and finally, we have the values. This is equal to minus 5 plus or minus 2I is m. That is m1 is equal to, we found m1 is equal to minus 5 plus 2I, and m2 is equal to minus 5 minus 2I. Okay, fine. Therefore, we found from here it is that actually that is P, the real part is equal to minus 5. Okay, the real part is equal to minus 5 and the imaginary part Q is equal to 2 is there. Fine. Therefore, we can write the general solution. Therefore, the general solution is, therefore, general solution is y is equal to e raised to px, y is equal to e raised to px, e raised to px into a cos qx plus b sin qx is there. This is the general formula for of the general solution of the given differential equation. So, dear students, we can replace the value of p and q here. We found the p is equal to minus 5 and q is equal to 2. So, we can replace that two values there. Therefore, general solution is the y is equal to e raised to, the value of p is equal to minus 5. Therefore, minus 5x, e raised to minus 5x into a cos, the value of q, the q is equal to 2, a cos 2x plus b sin 2x. Fine. This is the general solution. This is the general solution is the general solution of given differential equation is the general solution of given differential equation. So, we found this is the general solution of the given differential equation. Okay, my dear students, I would like to take your attention to one more question. Write down the question as y double dash, the question, solve the differential equation y double dash plus 4y dash plus 7y is equal to 0 plus 4y dash plus 7y is equal to 0 plus 4y dash plus 7y is equal to 0. Okay, see my dear students, here we can write the auxiliary equation. The auxiliary equation as part of solution, we can write the auxiliary equation as the auxiliary equation is the auxiliary equation of the given differential equation. I would like to put this given differential equation as equation number 1. Okay, so I would like to put this differential equation is 1, and we can write the auxiliary equation because y double dash only here, therefore m square plus 4m plus 7 equal to 0. Here a is equal to 1, b is equal to 4 and c is equal to 7. So, from this differential equation we understood these values. Okay, so now we got a quadratic equation in m, as because that is a second degree quadratic equation, we can find the value of m. M is equal to this is m is equal to minus b plus or minus root of b square minus 4ac divided by 2a. See my dear students, you just see to here b square minus 4ac, that is 16 minus 4 into 7. So, definitely we understood it is that the value inside the square root will be the negative, therefore, here will be the complex, the imaginary part of complex number will occur. Okay, fine. So, dear students, we can write m is equal to, that is m is equal to minus b, the value of minus 4 plus or minus 4 plus or minus root of b square, the value of b square is 4 square minus 4 into 1 into 7 divided by 2a, that is equal to minus b plus or minus root of b square minus 4ac divided by 2a, because because this is a monic polynomial, always the value of a is equal to this one 1, so that no problem. Here this is equal to minus 4 plus or minus root of 16 minus, that is 16 minus 4 into 7, 28 divided by this one 16 minus 28 divided by 2. Okay, say that is equal to minus 4 plus or minus 16 minus 28 is nothing, minus 12 is minus 12, am I right? Okay, sure, divided by 2, therefore we can write this is equal to minus 4 plus or minus. So, that is equal to minus 4 plus or minus I root 12 divided by 2, that is equal to minus 4 plus or minus, we can write this is equal to minus 4 plus or minus I into root 4 into 3 is 12, therefore, this is equal to minus 4 plus or minus I into, so root 4, that is root 4 into root 3 is root 4 is actually 2 root 3 divided by 2. Okay, we can take 2 is the outside of this, so 2 into, so instead of minus 4, minus 2 plus or minus I root 3 divided by 2. Okay, fine. So, now we can cancel this 2 and 2, finally we have this is equal to m is equal to finally we have m is equal to, therefore m is equal to minus 2 plus or minus I root 3, minus 2 plus or minus I root 3. Find the real part is equal to minus 2 and imaginary part is root 3. Therefore, we can say that this is equal to, therefore, m1 is equal to minus 2 plus I root 3 and m2 is equal to minus 2 minus I root 3. Minus 2 plus I root 3 and m2 is equal to minus 2 minus I root 3. See, this is minus 2 plus I root 3 minus 2 minus I root 3 is there. Okay, fine. Therefore, the general solution is, therefore, a general solution of given differential equation is, the general solution of the given differential equation is, that is y is equal to e raised to px, where p is the real part of this complex root, and a cos qx plus b sin qx. Okay, a cos qx plus b sin qx is there. So, okay, fine. So, we can write this is equal to the value of px, that is equal to, that is y is equal to e raised to px, that is e raised to minus 2x a cos root 3x, a cos root 3x plus b sin root 3 of x. A cos root 3 of x plus b sin root 3 of x is there. Okay, fine. Therefore, we have, this is the general solution of the given differential equation. So, this is the general solution of the given differential equation. Fine. Now, see, there we can find many questions, and there you can find many problems from the literature of the differential equation with the linear second order differential equation with the constant coefficient. We discussed the 3 methods to solve such a differential equation. See, write down some assignments. Solve the differential equation, y double dash plus 9y is equal to 0, and second one, solve the differential equation, 2y double dash plus 10y dash plus 25y is equal to 0, plus 10y dash plus 25y is equal to 0. Okay, the next one we can write this as 2y dash 8y dash, third one is solve the differential equation 8y double dash minus 2y dash minus y is equal to 0, minus 2y dash minus y is equal to 0. See, my dear students, these are just sample of differential equation that you can solve, but you don't limit your proficiency with these 3 differential equation. Try to work out more problems on the differential equation with the constant coefficients. That will be equip you with much more with this differential equation that have very great application in many fields of the basic sciences and engineering. Okay, thank you for watching this video. Thank you very much.